welcome to my channel Sai Suriyas Academy. If you are new to my channel, then hit the subscribe button and press the bell icon for more videos. In today's video, we are going to discuss about the number system used in the computers. Basically, what is a computer means? It is a digital system which stores and processes some data and gives some information. The digital system can able to understand only zeros and ones. But the programmers, we use the normal system, that is the decimal number system. We use alphabets for writing our coding, etc. So the computer programmers can use different number systems such as there are various number systems such as decimal number system, binary number system, octal number system, and hexadecimal number system. These number systems comes under the names called positional number system. We have to know about what is the positional number system. A positional number system is nothing but the number system in which the symbols, it can store the numbers as symbols called digits, and the values of those numbers can be represented by the position or can be determined by the position of the digits. This type of positioning number system contains all the number system what I have told earlier. Now we can able to how these number systems are used or how we can able to convert this number system. We can see in this video and the upcoming videos the conversions we can able to see. Now consider the number systems. The first one is the decimal number system. The decimal number system is the normal number system what we use in our day-to-day life. It consists of digits 0 to 9. It is called as a base 10 number system and it contains the digits 0 to 9. An example of this digit is 5219.32. This 5219 is called the integer part and 32 is called the fractional part. These two numbers are divided by a point which is called as the decimal point. That is the decimal system. Just by example I am representing. In the next videos we will talk about the conversions. And the next one is the binary system. This binary system consists of only zeros and ones. Other numbers are not allowed in this type. The binary numbers can be these zeros and ones are called the bits. So that number of 8 bits consists of 1 byte or number of 16 bits consists of 1 word. It can be represented in 1024 kilobytes or megabytes or gigabytes. So on, so it can be represented, the various values can be represented. It consists of a base 2 and the example of this number is 10110.110. Since it consists of only zeros and ones, the point which is separating this is called the binary point. And the next one consists of the octal number system. The octal number system consists of a base 8 number system. It is called as a base 8. Base 8 and it consists of digits 0 to 7. An example of this number is 352.26. Since it consists of 0 to 7, number 8 and 9 are not allowed. We can see here 8 and 9 are not allowed here and the point which is separating is called the octal point. And these numbers when represented in binary, it can be represented by 3 binary digits. For example, 0 is represented as 000. 1 is represented as 001. Similarly, for 0 to 7, when converting to binary, we can be able to see it can be represented as 3 binary digits. The next comes the hexadecimal, which consists of a base 16. Base 16 and it consists of digits 0 to 15. 0 to 15, how it is represented, you have to know first and then we will talk about the example. The 0 to 15 numbers, the first 0 to 9 numbers are represented as it is 0 to 9. Then how come the 10 to 15 numbers are represented? 10 is represented by A, 11 is represented by B, 12 is represented by C, 13 by D, 14 by E and 15 by F. And the numbers more than 9 comes, the alphabet we have to represent for 10A, 11B such that. So here comes the example 3A 9.5B. So how it represents means for 3 it is 3 only, for A it represents 10. Then 9.5B. Here B represents 11. And the point which it divides the integer part and the fractional part is called the hexadecimal part. The hexadecimal can be simply represented as hexa. So it is called as a hexa point. And the numbers when converted to binary, it is represented by a 4 binary digits. Just as it is for 0 and 1 I am representing. In the next classes we will see how it can convert the other numbers. Just as 0 can be represented as 0, 0, 0, 0, 4 digit binary numbers. 1 can be represented as 0, 0, 0, 1. Just for understanding only I am representing zeros and ones only, the values in hexadecimal. It can be represented by 4 binary digits. Then when talking about the positional number system, how the positions are calculated? It is calculated by adding a weightage to a particular digit and then multiplying those digits with the weightage. Consider an example of the decimal point 5219.32, the example what I had told here. Consider this, we have to add weightages starting from before the integer part. First take this integer part. With the integer part, the weightage will be given from the right to left. That is for 5219, this is considered as the integer part. This is 32 considered as a fractional part. In the fractional part, the weightages will be given from left to right. Just for your understanding, I am showing these arrows. So for 9, it is represented as 10 power 0. For 1, 10 power 1. The power comes increasing as it moves here. For 2, 10 power 2. And for 5, 10 power 3. And then consider the fractional part. Here we have to move from the left to right side increasing. And since it is integer, it is represented as a negative value, that is minus 1. So for 3, 10 power minus 1. For 2, 10 power minus 2. This is the positional values given for each digit. So with these positional values or the weightages, what we are going to do is, we are going to multiply these digits with the added weightages and add all those values, which is given as 5 into 10 power 3 plus 2 into 10 power 2 plus 1 into 10 power 1 plus 9 into 10 power 0. This is the integer part. plus the same way the fractional part has to be calculated, plus 3 into 10 power minus 1 plus 2 into 10 power minus 2. And then we are calculating the values. 5 into 10 power 3, which is 1000. So 5 into 1000, 5000. 2 into 10 power 2, 100. So 2 into 100, 200. 1 into 10 power 1, 10. So 10, 1 into 10. Plus 9 into 10 power 0. Any number to the power 0, its value is calculated as 1. So any number to the power 0 value is 1. So 9 into 1, 9. Plus 3 into 10 power minus 1. How the value is calculated is 3 into 1 by 10 plus 2 into 1 by 100. Since the value is minus, it is written as 3 into 1 by 10 plus 2 into 1 by 100. So what happens? 3 by 10, only 1 zeros, so 0.3. 3 by 10, which represents 0.3. And what happens here? 2 by 100, which is represented, which contains 2 zeros. So in the upper we have to, before decimal you have to have 2 digits, so 0.02. 0.02. And then we have to add all those numbers. 5000 plus 200 plus 10 plus 9, 5219. And then adding the decimal points, 0.3 plus 0.02, which gives the value 0.32, which is the decimal point value. In this method, the values can be calculated. That is the positional number system. We are adding a weightages to each digits, and then we are multiplying those weightages, and the sum of the products is given, which gives the positional number system values. For decimal number, just for example, I am calculating here. The next calculations will be in the other calculations will be continued later. So what are all the conversions we can able to do here? Here we have written decimal, binary, octal and hexadecimal. From decimal, we can able to convert the number to decimal to other 3 conversions. Decimal to binary, decimal to octal, decimal to hexadecimal. Similarly, from binary, we can able to convert to binary to decimal, binary to octal, binary to hexadecimal. Similarly, from octal, we can able to transfer to octal to binary, octal to decimal and octal to hexadecimal. And finally, from hexadecimal, we can able to convert to octal, binary and decimal. So when considering these 4, these are the 12 type of conversions what I had said, like decimal to binary, binary to decimal, decimal to octal, octal to decimal, likewise hexa to binary. These are the major 12 conversions we are going to see. And then the next type, what are the other conversions we are going to see? Each conversions have a different type of methods, but it will be very easy only for you to study. All the conversions have a slight modification depending upon the base. In the first thing we have already seen how a decimal point the weightages are calculated. Similarly, depending upon the base, each digit has a different positional values and different systems to calculate all these conversions, but everything is very easy only. And then next comes the next conversions, 4-bit BCD system, which can also be represented as 8421 coded system. What is this weighted 4-bit BCD system? BCD stands for binary coded decimal system, in which all the digits are represented by 4 binary digits. Similarly, in hexa we had discussed as 4 digits for 0, 0, 0, 0, 0, for 1, 0, 0, 0, 1. Similarly, all the 0 to 9 digits are represented as the 4-bit binary digits, 4 binary digits. which is also known as the 8421. This 8421 how comes means that is 2 power 0, 1, 2 power 1, 2, 2 power 2, 4, 2 power 3, 8. Depending upon the weightages, it is also represented as the 8421 code system. In this, we have two types, weighted 4-bit BCD code and XS3 BCD code. Each has a different type of conversions. We are going to see the two type of conversions also. And then within this 4-bit BCD system, these two systems are allowed. And then the next one is gray code to binary and then binary to gray code. These are all the conversions we are going to see in our next video. Once again, recalling some basic important points. Here we are discussing about the positional number system, decimal, binary, octal and hexadecimal. The decimal has a base 10 system, binary has a base 2 system, octal has base 8 and hexadecimal has base 16 number system. Each examples has been represented here. Decimal contains 0 to 9 digits, octal contains 0 to 7 and then hexadecimal contains 0 to 15 and then this 0 to 15, 0 to 9 are represented by numbers and then the from 10 to 10 to 15 it is represented as A to F. And then the decimal values, how the positional values is calculated, we had done here by adding the weightages. When adding weightages for integer part, we have to increase from the right to left, 10 power 0, 10 power 1, 10 power 2, 10 power 3. For fractional part, we have to start from the left to right and negative numbers values has been given 10 power minus 1 and 10 power minus 2. Like this the values are calculated and then the other type of conversions are those 12 conversions and then 4-bit BCD system. Okay, that's all for today's video. We will discuss all those conversions in the next video. Keep supporting Sai Suriyas Academy. Thank you.